Singularity. John von Neumann first used singularity in the 1950s to describe a hypothetical future point where technological growth, particularly artificial intelligence, would become uncontrollable and incomprehensible to humans. The term was later adapted in astrophysics by Roger Penrose and Stephen Hawking in the 1960s to describe the infinitely dense core of a black hole where the laws of physics break down. Its dual usage reflects both a speculative vision of human progress and a precise mathematical concept in cosmology. Complex number. Carl Friedrich Gauss popularized complex number in 1831 in his work on number theory, describing numbers with a real part and an imaginary part. Though the concept originated with Italian mathematicians like Gerolamo Cardano in the 16th century, Gauss's rigorous treatment and notation made it a standard tool in mathematics and physics. His advocacy helped overcome earlier skepticism, cementing its role in fields like quantum mechanics and electrical engineering. Molecule. Amadeo Avogadro introduced molecular in his 1811 paper on gas laws, defining it as the smallest particle of a compound retaining its chemical properties, derived from the Latin for small mass. His work distinguished molecules from atoms and laid the groundwork for Avogadro's law, which states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. This concept became fundamental to chemistry, though its full acceptance took decades as scientists debated atomic theory. Inertia. Johannes Kepler coined inertia in his 1609 book Astronomia Nova, using it to describe a planet's tendency to resist changes in motion unless acted upon by an external force like sun's influence. He derived it from the Latin iners, meaning idle or sluggish, contrasting Aristotle's view that objects naturally come to rest. Isaac Newton later defined this into his first law of motion in 1687, making inertia a cornerstone of classical mechanics. Cell. Robert Hooke coined cell in his 1665 book Micrographia, where he described the porous structure of cork under a microscope as resembling tiny rooms or cells, from Latin cellar. His observation of dead plant cells was the first documented use of the term in biology, though he didn't grasp their living function. Later, in the 1830s, two scientists built on this work to formulate cell theory, recognizing cells as the basic units of life. Biome. Frederick Clement introduced biome in 1916 to describe large-scale ecological communities like forests or deserts, defined by their dominant vegetation and climate interactions. He developed the term while studying plant succession, emphasizing how organisms and their environments form a cohesive system. It gained traction in ecology as a way to classify Earth's biodiversity, influencing modern conservation and climate studies. Half-life. Ernest Rutherford introduced half-life in 1907 to quantify the time required for half of radioactive substances' atoms to decay, a concept he developed while studying radium and thorium emissions. This term provided a precise measure for radioactive decay rate, revolutionizing nuclear physics and enabling applications like radiocarbon dating. His work with Frederick Soddy on radioactive decay series solidified half-life as a fundamental property in understanding atomic instability. Vector. William Rowan Hamilton coined vector in 1846 in his work on quaternions, defining it as a mathematical entity with both magnitude and direction, distinct from scalars which have only magnitude. He introduced the term from Latin "vihire," to carry, to describe spatial relationships in 3 dimensions, a breakthrough for physics and engineering. Vectors became essential in electromagnetism and fluid dynamics, with Joshua Willard Gibbs later refining their notation in the 1880s. Thermodynamics. In 1849, William Thomson introduced the term thermodynamics in his scientific paper. He combined 2 Greek words, thermi, meaning heat, and dynamis, meaning power. Thomson was building on earlier work about heat engines. He wanted to create a way to study how energy moves and changes from one form to another. He helped develop important ideas like absolute temperature. Working alongside another scientist named Rudolf Clausius, Thomson turned thermodynamics into a key branch of physics. Their work explained how heat and energy flow, which became crucial for understanding everything from steam engines to the workings of the universe. Plasma. Irving Langmuir coined plasma in 1928 to describe an ionized gas with free electrons and ions, noting its dynamic behavior resembled blood plasma's fluidity in living organisms. He introduced the term while studying electrical discharges in gases at General Electric, observing properties like conductivity and responsiveness to magnetic fields. Plasma became recognized as the 4th state of matter, comprising over 99% of the visible universe, including stars and nebulae. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.